Hello friends, today we will solve the GATE 2024 Electronics and Communication problem, network problems. So there are total 4 problems. This first problem is on two-port network. It is saying that for the two-port network shown below, the value of Y21 parameter will be. Okay. So this is the network. So there is a 2 ohm resistor, 4 ohm resistor, and this dependent source of minus 8 V1. Okay. So voltages and current are marked here, and we need to find the Y21 parameter. So there are two ways of doing it. First is like you want to solve it directly, then you can see that y21 is like nothing but I2 upon v1 when v2 is 0, because you see the equation of y parameter, I1 is y11 v1 plus y12 v2, y2 is y21 v1 plus y22 v2. So y21 is nothing but I2 upon v1 when v2 is 0. So when v2 is 0 means we need to short circuit the v2 part. Okay, so I short circuit the v2 part to remove or to make v2 0, and now we need to solve it. So let's see how we can do it. So first I can do one KVL here. Okay, so this will give us v1 is equal to 2 times i1 plus 4 times i1. Okay, and then it's 4 times i2 and minus 8 v1. So this will give us 9 v1 is equal to 6 i1 plus 4 i2, but we want only i2 and v1, so we need to remove i1. Okay, so to remove i1, what I will do is we will make one more KVL on this side. So this will give us 4 times i1 plus i2 minus 8 v1 equal to 0. So 4 i1 plus 4 i2 is equal to 8 v1. So 4 i1 is equal to 8 v1 minus 4 i2. So i1 is 2 v1 minus i2. So we want everything in terms of v1 and i2. Okay, so I will put it here. So this will be 9 v1 equal to 6 times 2 v1 minus i2 plus 4 v2, and this will be like this thing. 9 v1 is equal to 12 v1 minus 6 i2 plus 4 i2. So this is minus 2 i2. So this is like minus 3 v1 is equal to minus 2 i2. Okay, so i2 upon v1 is 3 by 2, so 1.5 Siemens. So that is one way. Another way to solve this thing is like since it is a T network. Okay, so since it is a T network, so what another approach can be like, first we will find Z parameter, because for pi networks y parameter is easy. Okay, you just need to apply two KCLs at two node, and similarly for T networks Z parameter is easy because we just need to apply two KVLs. So this KVL will give me this equation. Okay, minus v1 plus 2 times i1, okay, plus 4 times i1 plus i2 minus 8 v1 equal to 0. So I'm solving it. I am getting directly z11 and z12, because these are z11 and z12. v1 is equal to z11 i1 plus z12 i2. So this I am getting here. Okay, and then this second KVL will give me this equation. Okay, v2 is equal to 4 i1 plus 4 i2 minus 8 v1. Now we want only uh, i1 and i2 and v2. So to remove this v1, what I will do is I will use this one to remove this v1, and then on putting this and then simplifying, I get this thing. So basically I'm getting Z matrix, and now y matrix is y parameter matrix is nothing but inverse of Z matrix. Okay, so this is like a b c d, so inverse will be 1 upon ad minus bc, and then these things will be interchange, there will be a minus sign here. So when I do this, okay, when I take a inverse of this matrix and solve it, then again also what I get is I am only solving for this y21 part. So this will be 1.33 divided by 0.88. So again I am getting 1.5 Siemens. Okay, so there are two ways of doing it. This is like more direct approach, but this is like if you don't know how to proceed, then you can always apply two KVLs and get Z matrix for any T network. Okay, so this is second question. Second question is saying, in the network shown below, maximum power is to be transferred to the load RL. Okay, so the value of RL is, so it's clearly we need to find a RL value. So maximum power transfer theorem problem. So value of RL will be clearly RTH. Okay, because when RL is equal to RTH, then maximum power will be transferred to the load. Okay, so this problem also I have solved in two ways. Just give me a minute. Okay, so here what I will do is like first thing is like I am using Thevenin theorem to find VTH and RTH. Okay, so what I will do is like sorry, this is another problem. Yeah, sorry. So how I will proceed here is like first equation I am making, making from this thing. So since we need to find RTH, so what we will do is we will short circuit it. Okay, short circuit this voltage source. Okay, so this will be 0 volt 0 volt. Now this, and we will since there is a dependent source, so we will use VT IT method. So we will use this VT, and this is IT, so this is also VT, this is also VT. So this voltage will be VT minus Vx, and this voltage will be 0 plus Vx, so this is Vx voltage. Okay, now first equation I am making like this thing, and that 0 into 3 plus Vt into 2 divided by 2 plus 3 is Vt minus Vx. So this is I am making this first equation. Okay, because whenever there are two resistors and two voltages, then we can find this middle voltage using this technique, the 0 into 3 plus Vt into 2 divided by 2 plus 3 is this middle voltage Vt minus Vx. So when I write it like this and solve it, then I get relation between Vx and Vt, which is basically the 5Vx is equal to 3 Vt. So Vt is equal to 5 by 3 Vx. Okay, or Vx is equal to 3 by 5 Vt. So this Vt thing on both the nodes I am getting it as 5 by 3 Vx, and now on this side it is Vx and this side it is Vt minus Vx. Okay, so this is Vt is 5 by 3 Vx and Vt minus Vx is 5 by 3 Vx minus Vx, so this is 2 by 3 Vx. Okay, and similarly, and this is 5 by 3 Vx, and this is Vx. Okay, this part is Vx. So the current we can find out, I1 will be 5 by 3 Vx minus Vx upon 2, and here current will be 5 by 3 Vx, okay, minus 2 by 3 Vx by 3. So when I solve it, I get I is equal to Vx by 3, and I1 and I2 both equal to Vx by 3. So both the currents will be same and it will divide equally. Okay, so I total will be I1 plus I2, because this current which is coming here, since it is open circuit, so some will go here, some will go here, and it is divided into equally in two parts. Okay, Vx by 3 Vx by 3, so I total is Vx by 3 plus Vx by 3, so I total is equal to 2 by 3 Vx, 2 by 3 into, and then since we want Vt upon It, so we need to convert this Vx into Vt, so which is basically what, which is Vt is 5 by 3 Vx. Okay, so and Vx is 3 by 5 Vt, so this is 3 by 5 Vt, so this is I total is 2 by 5 Vt. Okay, so Vt upon It is 5 by 2, so 2.5 ohm. So RTH is basically 2.5 ohm. So this is the third question. It is saying that we need to find this current Ix, okay, in this circuit. So first way of solving it is using RTH and VTH method. So I will basically simplify this entire circuit, okay, and Thevenize it, so that this become easy. So how do I do it? First I will find VTH. To find VTH, what I will do is I will remove this branch and I will find VTH over this node. So I will remove it, and this is 1 kilo and 2 milliampere, and this thing is like that. So you can see that 5 milliampere is coming from here. Okay, and I node current is going here. Okay, and here 2 milliampere current is coming, so this 2 milliampere current is coming from here only, and 5 is coming here, so here this current you also know, this is 3 milliampere, so 3 is going here, 2 is going here. So now we need to find VTH, so we will apply one KVL here. Okay, we can apply one KVL. So this will be like what, minus 3 volt, because this is 1 kilo ohm and 3 milliampere, so this will be 3 volt. So minus 3 volt, and then it's minus 1000 I naught. Okay, I naught again is 3 milliampere, and plus VTH equal to 0, so VTH is 6 volt. Easy. So this is like minus 3 and minus 3 is equal to minus VTH, so VTH is 6 volt. Now to find RTH, since there is a dependent source, so I need to make VT upon IT method. So either I can take 1 ampere current source and make IT equal to 1, or I can make VT equal to 1 volt. So here I am using VT equal to 1 volt. Okay, and I will open circuit it, both these parts. Okay, so now you can clearly see there is just one loop, that IT will go here and it will go like this and like this and like this. Okay, so IT is nothing but I node only, clearly visible. So KVL will give us minus 1, and then plus 1000 I node, and then plus 1k into I node equal to 0. So this is 1000 I node, 1000 I node is 2000 I node is equal to 1, so I node is equal to 1 upon 2000, and which is basically IT. I node and IT are same. So RTH is nothing but what, 1 volt upon IT, so 1 upon 1 by 2000, so this is 2000 ohm, so which is 2 kilo ohm. So once VTH and RTH is found, so this is VTH, this is RTH. Now we need to find this IX, because we need to find current in this branch. Okay, so you can clearly see IX is 6 volt divided by total resistance 3k, so this is 2 milliampere. So that's the usual approach. Another approach can be to, just let me zoom in a little bit. Another approach can be like simply mark the current. So this is 5 milliampere coming here, 5 milliampere minus I node is going here, here I node is going. After out of 5 milliampere, I node is going here, so 5 milli minus I node will go there, and then 5 milli minus I node, now 2 milliampere is going here, so 5 milli minus I node minus 2 milli, which is basically 3 milli minus I node is going here. So all the currents are written in terms of I node, and now I need to just apply one KVL in a suitable branch. So this voltage we know, this voltage we know, and this voltage we know in terms of I node. So we'll solve it. So this is like minus I node into 1k. Okay, minus I node into 1k, minus 1000 I node. Okay, and then plus 1k into 3 milli minus I node equal to 0. So we need to take care of this milli and kilo here. We need to be careful. Okay. So this will be like 1000 into minus I node minus 1000 I node minus 1000 I node, and then this kilo or milli will cancel, so plus 3, and then this is like minus 1000 I node. So minus 3000 I node is equal to minus 3, so I node is equal to 1 upon 1000 ampere, which is 1 milliampere. Okay, so we need to find this Ix, which is 3 milli minus I node. So 3 milli minus 1 milli is 2 milliampere. So again we are getting the same answer as 2 milliampere. So two ways of doing it. Last question is like super easy. It is saying that in the, let me zoom in the circuit shown below, the switch S was open for sufficiently long time and is closed at time t equal to 0. The time constant of the circuit for t greater than 0 is. So we need to find the time constant of this circuit. Time constant is like always found after the switch is closed, so for t greater than 0. So once the switch is closed, so tau is defined for equivalent circuit for t greater than 0, and tau is equal to, since it is an RL circuit, first order RL circuit, so it will be L upon R equivalent. And what R equivalent? R equivalent seen across L. So we remove L and we find R equivalent or RTH across this part. Okay, so tau is L upon R equivalent across L, and R equivalent in the symbol RTH across L. So we'll find RTH across L. To find RTH across L means this thing, so this will be open circuit. Okay, and this will be 2, this will be 4, and this will be 4, and from here we will find the RTH. So you can see that these 4 and 4 are in parallel, so they will be 2, and these 2 and 2 are in series, so they will be 4. So R equivalent is 4. Okay, so basically tau is equal to L upon R equivalent. L is 3 Henry and R equivalent is 4, so 3 by 4, so 0.75 seconds. So 0 0.75 second is the correct answer. So these are the four questions.